Why does this seemingly perfect planet make scientists more and more uneasy? It has a habitable temperature, orbits a sun-like star, and may even harbor liquid water. It checks almost every box for what we imagine as Earth 2.0. That planet is none other than Earth's cosmic cousin, Kepler-22b. Its size exceeds the limit for rocky planets, yet it hasn't ballooned like a gas giant. Its orbit sits perfectly in the habitable zone. Theoretically, it should have moons or companion planets, but the space around it is strangely empty. No known tectonic activity, no gravitational disturbances. Its orbit is almost a perfect circle, as if it were precisely placed in the star's sweet spot. Every detail about it feels ... designed ... In fact, the data suggests it may be even more perfect than Earth. Mars venues are thought to be ITs, as if the universe had run multiple test iterations and landed on this final version, and yet it's this very perfection that makes scientists more and more uneasy. How Kepler-22b was discovered in 2009. NASA launched the Kepler Space Telescope to search for Earth-like planets across our galaxy. Rather than taking pictures, Kepler used a technique called transit photometry, observing the brightness of 150,000 stars over time. When a planet passes in front of a star, it briefly blocks some light, causing a tiny dip in brightness, just 0.01%. Kepler had to detect this exact dip 3 times in a consistent pattern, confirming it was truly a planet, not a random blip. Eventually, scientists observed a periodic dip in front of a sun-like star, Kepler-22, after 2.5 years of verification. NASA officially announced the discovery of Kepler-22b in 2011. The unique features of Kepler-22b, located 638 light-years from Earth, orbits a sun-like star orbital period, 290 days distance from its star, approximately 0.85 right in the middle of the habitable zone. If it has an atmosphere similar to Earth's, its surface temperature would hover around 22 degrees Celsius, 72 degrees Fahrenheit. Ideal for life as we know it. The unsettling questions, but here's where it gets strange. Kepler-22b is 2.4 times larger than Earth, right in the so-called Fulton Gap, a size range where planets aren't expected to form stable structures. It's neither a classic rocky planet, nor a typical gas giant. Its nearly perfect, circular orbit shows no signs of disturbance. Even more curious, the system itself is eerily clean. No moons, no other planets detected. It all feels ... unnatural, as if Kepler-22b were some kind of test planet set in place by the universe. For possible explanations, none entirely convincing. One super-Earth or large, rocky planet with a thick atmosphere. If the atmosphere is too thick, it could become a Venus-like hellscape. Too thin, and the planet's size remains unexplained. Too ocean world entirely covered in a deep global ocean, hundreds of miles thick, but without continents or tectonic activity. There would be no nutrient cycle to support life. Even if microbes exist, they'd remain primitive forever. 3 Mini Neptune, more like a small gas planet than a rocky one, but it orbits far too close to its star for a planet like this to have formed there naturally. If it migrated inward, what force pulled it in? For hybrid planet, a rocky core, water layer, and thick atmosphere, but current models of planet formation can't easily explain such a structure. A test planet. Kepler-22b challenges everything we think we know about how planets form. What's even more unsettling, its parameters seem just right. Size, 2.4x Earth, right on the edge of the Fulton Gap orbit. Perfect position at the outer edge of the habitable zone. Year length, very close to Earth's theoretical temperature, with an atmosphere, a comfortable 72 FIF. These details showed up individually. You might chalk it up to coincidence, but when everything lines up so perfectly, you have to wonder, is this really just another random planet? Or is it some kind of cosmic test sample? Do all these just right conditions hint at a deeper law of the universe, or even a deliberate design? Rethinking what we know are our current planet classification systems simply based on the peculiarities of our own solar system, Kepler-22b, may never give us a definitive answer, but it forces us to ask new questions. If a planet looks like it was made, could it mean that we, too, were designed? If you want, I can also give a quick explicable on the Fulton gap or other planet formation theories.